Let's check out most exciting and important question for the in-semester examination. In this in-semester examination, I have prepared certain question for unit number 1 and unit number 2, considering all previous examination question paper. So in this question paper set, first question is compare electrical and magnetic circuit stating clearly similar and dissimilar point. Yes, electrical circuit has flowing quantity current, magnetic circuit has flowing quantity flux. So comparison has to be made against current and flux. So this is very important. Comparison between electrical and magnetic circuit. Similarly, question number 2, define reluctance. Yes, reluctance is basically opposition offered by magnetic circuit to flow the magnetic fluxes. So reluctance is represented by letter S, and this reluctance is S is equals to L upon mu 0 mu R into L. So reluctance depends on length of magnetic circuit, again relative permeability, again area of cross section of magnetic core. Next question is state and explain Faraday's law, first and second law of electromagnetic induction. Yes, whenever current carrying conductor cut magnetic flux, EMF has to induce inside the conductor or coil. So this EMF has magnitude minus N and d phi by dt volt. This is EMF induced in a conductor or coil. Next question is obtain the expression for coefficient of coupling between two magnetically coupled coil. Yes, this is equal to mutual inductance between two coil. This is equal to K times M, K times L and C, L1 and L2. Similarly, question number 2, next question, define the terms magnetic flux density. Just magnetic flux density is D, flux per unit area, magnetic field strength E, MMF, product of number of turns and current is MMF, permeability, this is permeability, relative permeability, this is mu R, absolute permeability, this is again mu, Henry per meter will be unit. These definitions are important, and any 3 definitions or 4 definitions will be available in your question paper. Next question, explain what do you mean by statically induced EMF and define self-inductance and state factor affecting the value of self-inductance of the coil. Yeah, statically induced EMF means there is no rotation of magnetic circuit as well as current carrying conductor. So EMF induced, like example, transformer, no rotational parts available, but EMF induced in secondary winding of transformer. This is called statically induced EMF. And self-inductance is defined as L. This is equal to product of number of turns flux upon current. This is called self-induced EMF. Now, another question is what is magnetic circuit? For simple magnetic circuit without air gap, obtain the expression for flux. Yes, flux is flowing inside the magnetic circuit. So any such kind of magnetic circuit you can consider. This is simple magnetic circuit without air gap. I connect here some coil to produce magnetomotive force. Such kind of circuit you can explain and find the flux through the magnetic core. So this is flux. Another question, compare statically induced EMF, dynamically induced EMF. Yes, this is a repetitive question. Next, explain mutually induced EMF, define mutual inductance. This is equal to, mutual inductance is equal to M, and this depends on several factors, mu 0, mu R, and square area upon L. This is called mutual inductance of a coil, and these are factors on which it is depends upon. Next, derive the expression for energy stored per unit volume in the magnetic field. Yes, so energy stored will be E equal to 1/2 B square upon permeability. This is EMF. This is the energy stored in a magnetic field per unit volume. So B is magnetic flux density and this is permeability. Another, derive the expression for simple energy stored in a magnetic field. So this is equal to E equal to 1/2 L I square. So these are important questions for chapter number 1. Now chapter number 2, and in this there are 2 parts. First is electrostatic and second is AC fundamental. So in electrostatic, derive the expression for energy stored in a capacitor. So we know energy, capacitor can store energy. This is equal to E, or sometimes W also can be considered 1/2 CV square. This is the energy stored inside the electrostatic field. You have to express this energy equation for 6 or 8 marks. When two capacitors C1, C2 are connected in series, derive the equation for total capacitance. Also draw the circuit diagram. Yes, when two capacitors are connected in series, you have to find the equivalent capacitance. So C equivalent is equal to C1 C2 upon C1 plus C2. Define capacitance. We know charge in a capacitor is always proportional to voltage, and the proportionality constant is called capacitance. So charge is equal to C times V, and C is equal to charge by V. So you can define this. And for parallel plate, capacitance is equals to mu 0 epsilon 0 epsilon R A by D. This is capacitance for parallel plate, depends on permittivity, area of cross section of metal plate, and the distance between two plate of a capacitor. Next important question, define the terms electric flux density. Yes, this is equals to B D electric flux density. Electric field strength is equals to E. Permittivity is equals to epsilon. Henry per meter will be unit. Relative permittivity will be equal to epsilon R. This is for air equal to 1, and any other magnetic material this has some value. Absolute permittivity is epsilon 0, epsilon only, and this epsilon is equals to epsilon 0 and epsilon R. This is constant, has value 8.854 into 10 raised to minus 12. Another question is, draw the curve for voltage across charging capacitor. Yes, this is charging. So draw charging circuit when capacitor circuit, this DC supply is given with the help of switch to one resistor and capacitor, and find the charging current and IC charging current and voltage across this capacitor VC. Another question, similar question, discharging of a capacitor. So similar, just consider this same circuit, just remove this voltage source, just at the switch, one resistor and one capacitor. For discharging point of view, discharging current will be exactly opposite, I discharging. This is discharging of a capacitor through resistance. This is charging of a capacitor through resistance. So this is VC discharging, and the current is discharging current. So we should express the value of voltage across capacitor, charging current, discharging current. Next, derive an expression for capacitance of parallel plate capacitor. Yes, already we have done there. So C is equals to epsilon 0 epsilon R area by distance between two plate, and this is farad, sometime microfarad, and then nanofarad or picofarad. This will be unit for the capacitance. Next is part second, find RMS value, obtain the expression for RMS value of current in terms of its peak value. Yes, we know Vrms is equal to root 2, Vrms is equals to Vm by root 2, and Vm is equal to root 2 times Vrms. Similarly, this also applies to current. So Irms is equals to Im by root 2, and similarly Im is equal to root 2 times I RMS. So this is, sometime university can ask find RMS expression for RMS voltage, sometime can ask for RMS current. So you have to prepare for any single, just replace the variable current with voltage, voltage with current. So this is one expression, RMS value in terms of maximum value. So this is root 2, RMS value is equal to Vm by root 2. Define average value. Yes, I average, suppose for current, I average is equal to 0.637 times Im. So we can derive this expression. This is important one. The next question, define the term peak factor, crease factor. Yes, we have already taken inside the video. Define the terms waveform. Yes, waveform is a graph or plot of two or more alternating quantity with respect to time. Instantaneous value. Yes, in the waveform, all value with respect to time are instantaneous value. V1 of t1, V2 of t2. These are called instantaneous value with respect to particular time. Cycle is this is one positive half cycle. This is one full cycle. Time period, the time taken for one complete cycle is t second. Frequency is f. This is inversely proportional to time period. Then amplitude, this is maximum value, this is for voltage wave Vm, and for current wave this is equals to Im. This is called amplitude, maximum value of voltage and current. Explain the concept of phase difference. This is called phi. This is between two quantity. Suppose we have this signal and another signal is this. So this is phase difference between two alternating quantity. This could be positive, negative, and zero also. So phase is phi, difference between two alternating quantity. Another question, explain the concept of lagging and leading phase difference. Yes, this is lagging phase difference because t equal to 0, current has, suppose this is current I, this is equals to voltage, current has some negative value, this is called lagging phase difference. Leading phase difference means this is, suppose this is voltage and this is current, so V, and this is current I. So when t is equal to 0, current has something positive value, so this is called leading phase difference. Next concept, explain the concept in phase and out of phase. In phase means both quantity should start at 0. This is, so phi is equal to 0. And out of phase means, yes, phase displacement will be equal to pi. Phase is equal to plus minus pi, means 180 degree or pi radian.